Hello, Earth scientists. We're starting your last unit in your Earth Environmental course, and this is on the lithosphere. Week 1 is beginning with the discussion about what Earth was like millions of years ago. So we know tropical paradise may look sort of like this image here, but what do you think Earth may have looked like millions of years ago? So you have a little bit of information here that are some questions to think about, and you're making a paragraph discussion post about what you think Earth may have been like 4.5 million years ago. Next, you're going to learn a little bit about Earth and what early life on Earth was like and what prehistoric Earth was like. So watch this video, and then you're going to go to your online notebook and write a reflection based on that. So the specific topic is what was Earth like, and that is the reflection paragraph in your online notebook. So here's what your online notebook looks like for this week in the lithosphere module. So week 1, rock and roll, is your paragraph first. Remember, 3 to 5 sentences makes a paragraph. And here's your vocabulary for this particular chapter. And these are your blanks to fill in, reviewing vocabulary. Then you have some notes about rocks and the different types of rocks, rock cycle, and then weathering and erosion and mountain formation. So those are the contents for your online notebook, and make sure that you submit it in Canvas when you are finished. So your learning targets for this week are specifically looking at introduction to the lithosphere and particularly focusing on the rock cycle and plate tectonics and how Earth's materials move on Earth's surface. So we know that Earth's surface is made of about 25% land and 75% water. So we're looking at how Earth's materials can move, particularly focusing on the rock cycle. So you probably remember from 6th grade that Earth's surface is broken into the crust, which is really thin, and then the mantle, and then the outer and inner core. So Earth's materials can move around, and we'll talk about that shortly. So the Earth's surface is going to be broken into tectonic plates, which is going to include the crust and then the uppermost part of the mantle. So not all of the mantle, but just the uppermost part of it. So these tectonic plates move, and that's what is going to cause earthquakes. So anytime there's a release in that tension that builds up between the plates, then that will cause earthquakes to occur. And one thing to remember is that even though Earth's surface is made of 75% water, in those areas where you have ocean, for example, there is crust under the ocean. So it's not just water all the way through the Earth. When you have continent, it's continent all the way down. It's rock all the way down to the crust. The continents do not just bob on the surface of the water. And then when you have ocean, beneath the ocean is ocean floor, which is rock. So I just wanted to point that out so that there wasn't any misconceptions about that. So our surface is broken into these plates. And again, when those plates move, it is going to cause a release of energy, which causes earthquakes. And looking specifically at the different types of rocks in the rock cycle, we have igneous, sedimentary, and metamorphic rocks. So igneous rocks, remember your STEM IGN, which refers to fire. Igneous rocks are going to be caused by cooling magma or lava. So literally it's rock that has gotten so hot that it melted. So that is a whole lot of heat energy that has to be applied to it. So igneous rocks are usually going to be very fine grained. You may not even see the grains in the rocks, and ones like obsidian are going to be very shiny. Sedimentary rocks. Sedimentary rocks usually are going to be more easily broken, and sedimentary rocks are going to be made of sediment, and sediment is just pieces of rocks basically. So rocks and minerals, some organic matter, things that get compacted together are going to cause sedimentary rocks to form. And a lot of times you're going to find fossils in sedimentary rocks, like this picture that has coquina shells in it. Limestone is another example of sedimentary rock, sandstone. And then metamorphic rocks. So metamorphic rocks, morph is referring to the shape or the form changing. So metamorphic rocks are going to have are going to be changed due to extreme heat or pressure. So if you take something like limestone and it gets compressed with heat and pressure over time, it's going to turn into marble. So this video is going to help you to learn about identifying rocks, and you don't have to learn how to identify specific rocks, but this will just help you to have a better understanding of that. And then when you look at your online notebook, you're going to jot down a little bit of information about the different types of rocks. So this rock cycle is going to help you to see how different types of rocks will change and how they can go from being one type of rock to another. So with any type of rock, if you have heat or pressure that's applied to it, it can metamorphose. It can turn into a different type of rock because of the extreme heat that may be applied to it. If you have weathering that is applied to any type of rock, then that force of weathering is going to cause that rock to break down into little tiny pieces. So the rock cycle doesn't have a start and a stopping point. There's no beginning and end to it. It just continually is has rocks that are kind of being shaped and formed throughout our surface, and this applies to rock layers and mountains as well. So it's the continual formation, breaking down, and reformation of rocks and depositing of these sediments. So when you are looking at this interactive, this rock cycle interactive here, you're going to be answering these questions about your rock cycle interactive. And number 10 on here, I have a specific note that this says to draw and label the rock cycle. So you can draw that if you would like to on paper and then take a picture of it and upload it. That's fine. You can also use Google Draw if you want. You can copy and paste pictures that you like, so different types of rocks. And then you can use Google Draw to draw your arrows. So you can produce this rock cycle image in a variety of ways. However, you should not be copying and pasting an entire rock cycle picture from the internet. This is about producing the rock cycle image on your own. And then you type up the answers to these questions here and submit that. So there's a little video here that Miss Bond has created, and it's a crayon rock cycle demo. So this is going to help you to see how to kind of compare crayons to sediments and different types of rocks. So the tectonic plates on Earth's surface are constantly moving. They move about an inch per year, which doesn't seem like a lot, and we don't feel them moving either. But the plates do move about an inch per year. In some places where there's a lot of tectonic activity, you can actually see the results of that. Like in California, there's a lot of tectonic activity, of course, because they have earthquakes all the time. So you can actually see sidewalks that are no longer lined up as they originally were formed or were produced, but they are several inches shifted, foundation of houses that are starting to see results. So there's a lot of changes that you can visually see in our surface and in man-made features because of this tectonic activity. So here's a little video that's going to help you to have a better understanding of weathering and erosion and deposition. So you're going to take notes in your online notebook about physical and chemical weathering specifically. So we know that the Appalachian Mountains are a huge mountain range that are near us. It's the biggest mountain range that is near us. They are more rounded mountains than the Rockies. So the Rocky Mountains, if you've ever been to Colorado, they're beautiful and they can go up to about 14,000 feet. And when I was hiking in Loveland Pass in Colorado, like that area goes up to 14,000 feet, and it has such a high altitude that the oxygen is lower, and it actually will cause you to have altitude sickness and cause your nose to bleed, and your body will feel results of not having enough oxygen because the altitude is so high, which is another reason why people who hike on Mount Everest take a lot of oxygen with them, because again, not enough oxygen, not as many air molecules, which we know from our study of the atmosphere. So the Appalachian Mountains are rounded because they have weathered a lot. They have shrunk, basically. So they used to be taller, and they used to have basically sharper points, sharper peaks to them, but they're more rounded now because of the erosion. So eventually, maybe millions of years from now, the Rocky Mountains, which are very pointed and younger mountains, maybe they'll be shorter and eroded as well. Plate tectonics. So this is a great picture showing you Earth's surface, and you can see the smaller outlines here are showing you the continents, the location of the continents, and then the bold lines are showing you the outline of those particular plates. So this is the North American plate, which oddly enough has North America on it. South American plate, South America is on that. So a lot of these plates are named for the continent that may be on them, although some of them don't have continents on them. And then you have the different little arrows pointing to the movement of that particular plate. So when you have plates that are pulling apart, that would be a divergent plate boundary because you have them going in different directions. So this is going to be where your mid-Atlantic ridge is, the mid-ocean ridge. So on the mid-ocean ridge, we know seafloor spreading occurs. So from the coast of North America here to the coast of Europe and Africa, you're going to have new ocean floor that's created along here, along this boundary, because this is pulling apart, pulling apart, pulling apart, pulling apart, pulling apart. So all of that is diverging. So that means you've got seafloor spreading that is occurring there on the bottom of the Atlantic Ocean, which is creating new ocean floor. Then when we have convergent plate boundaries, you have plates that are pushing toward one another. So in this area here, for example, these plates are converging. They're pushing toward one another. So you may have mountains that form. If they're continental plates, you may have subduction that occurs where one plate pushes under another plate. And when you have subduction occurring, then you also can have a lot of volcanic activity from that pressure. And also the plate that is subducting is going to be moving downward. And so it basically moves downward. It gets pushed downward to where it heats up from the extreme heat at the inner core, and it ends up melting and becomes basically part of the magma chamber. So that adds more magma that can pop up as volcanoes or hotspots. You can also have trenches form as well at those locations. And then when you have a boundary like this one, San Andreas Fault, you have transform movement. So one plate is moving up, the other plate is moving down. So when they are sliding horizontally past one another, that is when you have a transform plate boundary. So divergent plate boundaries, plates pulling apart. Convergent plate boundaries, plates are moving together. Con means together. You can also have subduction occur. This is subduction occurring. The plate goes under the other one. So this plate is coming this way. This other one is going towards it, but also gets pushed downward. So the plate that is of greater density is pushed downward. And then this ends up getting so hot that it melts. So that just adds to this magma chamber. And then transform plate boundaries, two plates are going to slide past one another. So this is at the San Andreas Fault. So one plate's moving down, the other one's moving up. And this is a picture just to show you the San Andreas Fault. I thought that was a cool image. Also, one abbreviation that you're going to see here and are going to see probably in a couple different places, OO convergence. OO is referring to ocean plates. So OO is ocean. So this plate is oceanic plate. This plate is oceanic plate. So that's because you have ocean on top of it. OC convergence. O refers to ocean. C refers to continental. So you have ocean plate right here, and this is a continental plate right here. So again, the plate that is of greater density is going to be the one that is subducting, and then this one is of lesser density, so it is not subducting. And then continental convergence, when you have the CC convergence here, this plate is moving towards it, this plate is moving towards the plate, so they're moving together, and you can have mountains that form as those plates are crashing into one another. Because they're of equal density, they're both land plates. So that causes those plates to smash together, and some of that land area gets forced upward. causing mountains to form. So this is just showing you some different plate boundary features, which we already looked at. And next is going to be your yummy lab about plate tectonics. So I'm going to set up some materials at school, and I'll have them set up on Wednesday. So if you would like to come to school or come to my classroom during PE on Wednesday, then you may do that, or you can just do the lab at home if you'd like, either way. So you do need these materials: a couple of graham crackers, wax paper, one Rice Krispie treat, frosting, some water, and a plastic knife. So you're going to need to upload four pictures as data. So make sure that you have your phone or have a camera so you can take some pictures of that to upload into your lab notebook, so that you can submit that when you are finished. So again, if you want to come to my classroom on Wednesday, then you can do that, or you can do the lab at home and submit it. So here is your lab write-up. So there's the section for your pictures to go. And then these are the questions that you're answering for the analysis. So make sure you have all the answers on your lab write-up before you submit it. And then when you are done with the week, then go ahead and take your quiz. You have 2 attempts at it, but you probably do not need the 2 attempts. So good luck, and let me know if you have any questions.